Hello everybody, welcome into another lesson. So today we are going to graph more trig functions. And today's focus is going to be on the secant and cosecant functions. So the secant function, of course, is the reciprocal of the cosine. And I have graphed the secant of x here. Well, in between these curves, you can literally graph the cosine of x function, and you would see that all these U shapes, these parabola looking things, they ride the back of the cosine function, so to say. So we know at 0, the cosine of 0 is 1. So it rides the back of it. It's going to go up like that. Then the cosine of pi is -1. It would go down like this. And it's going to do this infinitely. It'll do this to infinity. Now, much like your cosine function, you have an amplitude, which is the coefficient on your function, the secant of x. It's really the absolute value of 1, which is just 1. The period is still 2 pi. That hasn't changed. However, your domain is different this time. So if we put in -3 pi over 2, -pi over 2, +pi over 2, or 3 pi over 2, the cosine of all those is 0. Well, 1 divided by 0 is undefined. So you can't allow those in your domain. So the domain is all real numbers except where x equals odd multiples of pi over 2. X cannot equal odd multiples of pi over 2. That actually creates a vertical asymptote at all those points. And it'll do that infinitely. Now your range, on the other hand, also changes. So your range, as you can see, goes from -infinity to -1 inclusive. And then you have a gap between -1 and 1 where there's no values that equal anything between -1 and +1. And then you jump right from 1 inclusive to infinity. That's your range. So here is your graph of the standard secant of x function. And of course now it's time to follow suit and do the cosecant of x. So let's go ahead and do just that here. Alright. At least I don't have to erase it all. I have to erase like half of it, but something crashed. I'll get it later. Let's find -3 pi over 2. -pi over 2, +pi over 2, 3 pi over 2. Alright. And of course now it's time to proceed with the cosecant of x. So we're going to deal with f of x equals the cosecant of x. Well, the cosecant of x, as you know, is the reciprocal of the sine of x. Your amplitude is still 1. That's the coefficient on your cosecant, really the absolute value of 1, which just gives you 1. Your period is still 2 pi. That hasn't changed. Now, we need to look for in the domain for any values that would make this undefined. So the cosecant of 0, well, the sine of 0 is 0, so 1 over 0 is undefined. So you have a vertical asymptote at x equals 0. You have another one at pi, because 1 over 0 is 0, because the sine at pi is 0, so 1 over 0 is 0. So let's draw that asymptote. And then you have 2 pi is yet another vertical asymptote. And then you have again at negative pi and negative 2 pi. Alright, so there's all of our vertical asymptotes. Now, what does that mean? In your domain, x cannot equal integer multiples of pi. So, any integer multiple of pi will be excluded because you'll get undefined expression. You'll get an undefined expression. So no integer multiples of pi, which means your asymptotes are going to be where x equals integer multiples of pi for the cosecant function. Alright. Well, your range still stays the same, from negative infinity to negative 1, nothing in between negative 1 and 1, and then you go from 1 to infinity. So let's graph this. Alright, so 0 is undefined. Pi over 2, the sign is 1, so that means your curve is going to go like this. Ride that asymptote. The asymptotes help guide the curve. 3 pi over 2, your sign is negative 1, so it's going to go down like this. And then let's see, negative pi over 2 is also negative 1, so it's going to come down like this. And then negative 3 pi over 2 is positive 1, so here's what that's going to look like from negative 2 pi to negative pi. So this graph is going to do this infinitely. It'll do it infinitely with the asymptotes and all that. And just like the secant rode the back of the cosine, so to say, the cosecant rides the back of the sine function. You can literally, between these peaks, between these curves, you can draw the graph of the sine of x function, and you'll find it rides the humps of the sine of x. So those are basic secant and cosecant. Now, let's get into some reflections here. And I think we'll actually start with cosecant today, reflecting that. That way we can keep our asymptotes roughly the same, or exactly the same in this case, but it's going to change what we have for what it looks like since we're reflecting. Alright. Okay. Now, let's deal with reflecting. F of x equals negative cosecant of x. So now we have a reflection in the x-axis. We haven't changed anything. We haven't changed the amplitude or the period. So the amplitude, of course, would equal the absolute value of negative 1, which would just give you 1. So that hasn't changed. Your period stays the same. Your domain is still the same. It can't equal integer multiples of pi. Your range is even still the same. Your asymptotes are the same. The only difference is you have a reflection in the x-axis. Alright, so having said that, why don't we go ahead and graph this? So we know at 0 it's undefined. Pi over 2, the normal cosecant at pi over 2 is 1, but with that negative sign it actually makes it negative 1. So it's going to come down like this. 3 pi over 2, normally the cosecant's negative 1. If you negate that, you'll actually get positive 1. Negative pi over 2 is normally negative 1, but if you negate that, you'll get positive 1. And then negative 3 pi over 2 is normally positive 1. If you negate that, you get negative 1. So there is your reflected graph of the cosecant of x. Everything's reflected in the cosecant of x from normal. It's reflected in the x-axis from its normal position. Normally these would be flipped around, but you've reflected, so it's reflected the normal positions in the x-axis. And yes, I will do one even with the secant. All right. So let's do f of x equals negative of the secant of x. So again, your amplitude is going to be that absolute value of your coefficient of negative 1, giving you an amplitude of 1. That hasn't changed anything. Your period's still 2 pi. Now, let's go ahead and plot all the critical points here. So 2 pi. So here's 3 pi over 2. 6, 5. Here's pi. Here's pi over 2. Negative pi over 2. Negative pi, negative 3 pi over 2, negative 2 pi. All right, so there's all of our critical points plotted. Now we have to ask, where is the function undefined? Now in the secant, that's going to be at odd multiples of pi over 2. So x cannot equal odd multiples of pi over 2 in our domain. Which would have to mean the asymptotes are at x equals odd multiples of pi over 2. Alright, so let's go ahead and plot our asymptotes here so we can really get the graph of this. Plotting all the asymptotes at the odd multiples of pi over 2. Alright, so there's our asymptotes. Now, so let's start at 0. Secant of 0 is normally 1, but if you negate that, you'll actually get negative 1. So let's go ahead and go down like this. And now let's see. At pi, it's normally negative 1, but if you negate that, you'll actually get positive 1. And then at 2 pi, it's normally 1, but if you negate it, you'll end up getting negative 1. Alright, now secant at negative pi is normally negative 1, but you negate that, you'll actually get positive 1. And then the secant at negative 2 pi is normally 1. You negate that, you'll end up getting negative 1. So there is your graph of the secant of x reflected in the x-axis. Everything's flipped upside down from what it normally is. Alright, so there's reflections. Now let's talk about vertical shrinks and stretches of these functions. We'll start with the secant this time, since we already have all the asymptotes present. That might make it easiest, so we don't have to keep constantly erasing and starting over. Alright, this is going to change. That's not going to change. This is going to change. We're not going to be reflecting this time. Okay. Now what if we had something like f of x equals 2 times the secant of x? So all of a sudden now we have a coefficient other than 1 on the secant of x. Well, your amplitude is going to be the absolute value of that 2, which of course is 2. So, much like with your sine and cosine functions, it's the same with the secant and cosecant. A change of amplitude affects your range. It does not affect your domain, but it does affect your range. So, the range now, if you take all the members of the range and multiply that by 2, you'll end up going from negative infinity to negative 2 inclusive. And then you'll have from 2 inclusive to infinity. So you'll have nothing between negative 2 and positive 2. Your domain still stays the same. All x except odd multiples of pi over 2. Your asymptotes are x equals odd multiples of pi over 2. Alright, so the secant at 0 is 1 times 2 is actually 2. Okay, and then pi, the secant at pi is normally negative 1. Take that times 2, you'll get negative 2. And then, of course, 2 pi now normally is going to be 1. Take that times 2, you actually get 2. Alright, and then secant of negative pi is normally negative 1. Take that times 2, you'll be down at negative 2. And then secant of negative 2 pi is normally 1. Take that times 2, you'll get 2. So, as you see, there's just a greater gap between the upper curves and the lower curves. There's just a greater gap. That's what this vertical stretching is doing. You have a vertical stretch by a factor of 2. Okay. Now we're going to affect the cosecant one. Let's affect our cosecant. All right. So let's see here. First, let's plot our critical points. Alright, so there's all of our critical points marked on the x-axis. Now, This time we're going to vertically shrink. Let's do 1/2 of the cosecant of x. So f of x equals half of the cosecant of x. So the amplitude would be the absolute value of that 1/2, which of course would be 1/2. That's your amplitude, which is going to affect, again, not your domain, but your range. So take the members of your range, multiply it by 1/2. You'll end up going from negative infinity to negative 1/2 inclusive, in union with positive 1/2 inclusive to infinity. Your period's still 2 pi. We're going to get to period changes in just a minute here, but let's go ahead here. Let's talk about the domain. Again, where is the cosecant undefined? The cosecant is undefined at integer multiples of pi. So x cannot equal integer multiples of pi. Alright, and then that means the asymptotes are at x equals integer multiples of pi. So let's go ahead and plot the asymptotes. We know at x equals 0 is an asymptote. There will be another one at pi. Let's plot those asymptotes so we can help guide the curve. Another one at 2 pi. Let's see, 0's asymptote, negative pi is an asymptote. And then again at negative 2 pi. Alright, so let's start with the cosecant of pi over 2. That's normally going to be 1, but take half of that, you're actually at y equals 1/2. So we'll come up like this. Take the cosecant of 3 pi over 2, that's normally negative 1, but take that times half, you're actually only going to have y equals negative 1/2. And then, let's see, negative pi over 2, you also get negative 1. Take half of that, you'll end up getting negative 1/2. And then negative 3 pi over 2, you normally get 1. Take half of that, you'll end up getting y equals 1/2. So as you can see, you vertically shrunk this. There's less of a gap between the upper curves and the lower curves. Thus, your range is negative infinity to negative 1/2, and then from 1/2 to infinity with nothing in between. So those are your vertical shrinks and stretches. Let's talk about, let's do vertical and horizontal shifts. First, we'll do vertical shifts. Those are probably the easiest. Let's do a vertical shift. All right, let's start with the secant of x. So f of x equals, let's say 3 plus the secant of x. x. So, of course, much like with your sine and cosine, or really any other function in general, you have a constant plus your function. If you see that, that means it's a vertical shift up or down. In this case, we have a vertical shift up 3 units. Okay, so there's your vertical shift. Now, what is the amplitude? Just look at the coefficient on the secant of x, that's 1. So your amplitude's the absolute value of 1, which means your amplitude is 1. Now, let's actually speak to the range first. If your amplitude is 1, isn't your normal range from negative infinity to negative 1 and then from 1 to infinity? Well, this vertical shift up 3 changes your range. So you've got to add 3 to all the members of your range. Well, negative infinity plus 3, that's still negative infinity. But if you take negative 1 and add 3 to that, you'll get positive 2. And then if you take your positive 1 and add 3 to that, you'll end up getting 4. So this changes your range from negative infinity to positive 2 in union with 4 to infinity. So this is going to change things a bit. Alright, let's look at your domain. So where is the secant of x undefined? In fact, it might help again if I plot these points. Only cause of the asymptotes, there's a lot of erasing. I do apologize for that. But I would rather teach it right than, you know. Alright, so we got our critical points plotted. Where's the secant of x undefined? That's going to be at integer multiples of pi over 2, right? So the domain is all x except it cannot equal odd multiples of pi over 2. If I said integer multiples of pi over 2, I'm sorry, that was wrong. It's odd multiples of pi over 2. So that means your asymptotes, again, would be at x equals those odd multiples of pi over 2. So let's go ahead and plot these asymptotes, just for simplicity's sake. Alright, so we got our asymptotes plotted. Now let's start at the secant of 0. That's normally 1, right? But then you add 3 to that, you're actually all the way up to 4. So you'll actually be all the way up at 0, 4. So here's your curve. Now, what is the secant of pi normally? That's normally negative 1, so if you add 3 to that, you'll be actually up at positive 2. And yes, your curve is actually going to cross through the x-axis. You will have that sometimes when it's shifted. Then the secant of 2 pi is 1 plus 3 is 4. Alright, secant of negative pi is normally negative 1 plus 3 is actually 2. And then the secant of negative 2 pi is 1 plus 3 is 4. So there you go. There is your curve shifted upward 3 units, and you can see you actually do have a couple points on here where it crosses the x-axis. And it'll happen infinitely. Now let's do a shift with the cosecant of x. Yeah, we'll leave that. We're going to do a vertical shift on the cosecant this time. So f of x will equal -2 plus the cosecant of x. So f of x equals -2 plus the cosecant of x. Alright, so that -2 plus that means it's going to be a vertical shift down 2 units. So we have a vertical shift this time down 2 units. Okay. So that's also the vertical shift affects our range. So of course negative infinity is still negative infinity. That hasn't changed. Now normally that goes to -1. If you subtract 2 from that, you'll actually go from negative infinity to -3 inclusive in union with, now normally positive 1's the other part of the range, but take -2, you would actually have -1 to infinity. So you just subtract 2 from your normal members of the range, and there's your new range. And of course, I probably better plot all my critical points for the graph. Alright. Now, where is the cosecant of x normally undefined? That's going to be integer multiples of pi. So the domain is all of x except x cannot equal integer multiples of pi. Alright, so the asymptotes are going to be at x equals those integer multiples of pi. Alright. I'm going to draw said asymptotes here. So let's see, integer multiples of pi, we know it's there at 0. Let's draw an asymptote at pi. Let's see, negative pi. -2 pi. All right. So let's see here. The cosecant of pi over 2 is normally 1, but if you subtract 2 from that, you'll actually be down to -1. And yes, you're actually going to cross the x-axis here. Now the cosecant at 3 pi over 2 is normally -1. If you subtract 2 from that, you'll be all the way down to -3. And then negative pi over 2, the cosecant is normally negative 1. Subtract 2 from that, you'll be down to negative 3. Cosecant at negative 3 pi over 2 is normally positive 1. Subtract 2 from that, you'll be down to negative 1. With another crossing of the x-axis, actually in a couple spots. So your graph is going to look a lot like this with everything shifted downward 2 units. So there's your vertical shifts. Let's talk about some horizontal shifts. Yeah, let's stick with actually, let's stick with the cosecant of x. No, let's not. It won't matter because with these changes, everything else could change too. All right. So f of x equals the secant of the quantity of x minus pi over 2. So much like with your sine and cosine functions, if you have a quantity, x plus or minus a quantity, this denotes a horizontal shift. So set that x minus pi over 2 equal to 0, you'll get x equals pi over 2. So actually you have a horizontal shift to the right pi over 2 units. Let me plot our critical points here, because whenever you have a horizontal shift, that's going to affect your asymptotes also. Alright, so everything shifted to the right pi over 2. So, with your normal secant of x, and it might actually help to list the asymptotes. With your normal secant of x, where is your function undefined? That's going to be at odd multiples of pi over 2. Well, if you shift that pi over 2 to the right, so if you add pi over 2 to that, you shift everything to the right, you're suddenly now at integer multiples of pi. So the asymptote will be at x equals those integer multiples of pi. So, though this is a secant function, it's actually starting to behave like a cosecant function. So now that our asymptotes are at those integer multiples of pi, that means that our domain is everything except for x equals those integer multiples of pi. Alright, and then our range, well, our coefficient's 1, the amplitude's still 1, period's still 2 pi. After we talk about horizontal shifts, we'll talk about period changes. That'll be the next thing. But, so the secant has a coefficient of 1. We have no vertical shifts, so your range is still going to be that negative infinity to negative 1 inclusive in union with 1 inclusive to infinity. Alright, we have enough information to graph now. So this time our asymptotes will be at 0, they'll be at pi. and then they'll be at 2 pi. Everything shifted to the right pi over 2 units. Alright, negative pi. And then again at negative 2 pi. So yes, this is starting to behave a lot like a cosecant graph, even though technically it's a secant function. Okay, so we know if we actually put in 0, you'll get the secant of negative pi over 2, which would be undefined. So if you put in pi over 2, you'll get the secant of 0, which is 1. Where normally the secant of pi over 2 is undefined, you have a shift to the right of pi over 2 units. And then the secant of 3 pi over 2, if you put in 3 pi over 2, you'll actually end up getting the secant of pi, which is negative 1. And then if we put in negative pi over 2, you'll get the secant of negative pi, which is also negative 1. Alright, then the secant, let's see, that's 3 pi over 2. Okay. If you put in negative 3 pi over 2, you'll get the secant of negative 2 pi, which is actually 1. So as you see, this really looks very much identical to the cosecant of x. So that's how horizontal shifts can affect this. And yes, you knew it was coming. We're going to do a horizontal shift on the cosecant function. Let's go ahead and do that. Then we'll do a couple period changes. Then we'll do 2 final ones where we have everything thrown at you with several transformations. That's not going to, let's see. That shouldn't change. This will change. Alright, so this time we have f of x equals the cosecant of x plus pi over 2. This denotes another horizontal shift. If you set x plus pi over 2 equal to 0, you'll get x equals negative pi over 2. So you have a horizontal shift left pi over 2 units. So everything's shifted to the left pi over 2 units, which is actually going to shift your asymptotes. Where is the cosecant of x normally undefined? It's normally going to be undefined at integer multiples of pi. But if you shift everything to the left pi over 2, you're going to get odd multiples of pi over 2. So x cannot equal those odd multiples of pi over 2 this time. Which means the asymptotes will be x equals odd multiples of pi over 2. So suddenly, this is going to behave a lot like a secant function, even though technically it's still cosecant. Your amplitude's still 1, that hasn't changed. Your period's still 2 pi. Your range is still from negative infinity to negative 1 in union with 1 to infinity. Let's plot those critical points and then let's do the graph. So here's 2 pi, 3 pi over 2, pi, pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. Alright, so the asymptotes are going to be at odd multiples of pi over 2. So let's go ahead and graph these asymptotes to start. So yes, it's starting to behave a lot like a secant graph. All right. So let's do the graph now. So if you put in 0 for x, normally the cosecant's undefined at 0, but if you add pi over 2, you'll get the cosecant of pi over 2, which is 1. And then if you put in pi, normally it would be undefined there, but pi plus pi over 2 actually gives you 3 pi over 2. The cosecant there is negative 1. And then 2 pi plus pi over 2 is the same as just pi over 2, which would just be 1. That's a whole pi over 2 past a full circle. Okay. Negative pi plus pi over 2 is the same as negative pi over 2, which would give you negative 1. And then negative 2 pi plus pi over 2 is the cosecant of negative 3 pi over 2, which is positive 1. So yes, as you see, this is technically a cosecant function, but the graph behaves identically to the secant of x. Alright, 4 more graphs to do. 2 of them are going to be talking about period changes, and then the final 2 are going to be several transformations thrown at you at once. So we'll keep the amplitude the same. So what if, well, in general, let's say I have either the secant or cosecant of bx, right? This is true whether you have the secant or the cosecant. Much like yesterday when we talked about sine and cosine. Your period is going to be 2 pi divided by that coefficient on the x. So the period is really 2 pi over b. It's just up till now it's always been 2 pi divided by 1, so that's why we haven't had anything other than 2 pi. That changes now. And we'll start with the secant. So we're going to take f of x equals the secant of 2x. So f of x equals the secant of 2x. So the period is going to be 2 pi divided by 2, which would give you a period of pi. So now we suddenly finish everything in pi. So let me label those points on the graph. Here's going to be, let's see, 3 pi over 4. Here's going to be pi over 2. Here's pi over 4. Negative pi over 4. Negative pi over 2. Negative 3 pi over 4. And then negative pi. So the periods change to pi. Now, we need to talk about the domain and the range and the asymptotes. So here's an easy trick for your domain. Where is the secant of x normally undefined? It's normally undefined at odd multiples of pi over 2, right? Well, if you divide your period by 2, you're going to divide your asymptotes by 2. Your asymptotes will also be at odd multiples of pi over 4. So x equals odd multiples of pi over 4 will be your asymptotes, which means the domain is all reals except x not equal to odd multiples of pi over 4. So you can divide your asymptotes by 2 also. Okay, so let's actually plot those asymptotes. And your range hasn't changed. Your range is still that negative infinity to negative 1 and then 1 to infinity. So if I put in pi over 4, that gives me the secant of pi over 2, which would be undefined. So you're going to begin to see how this is going to work. So yes, whatever you divide your period by, that's what you can divide your asymptotes by to get your asymptotes and your domain. That's a very nice, easy trick. Alright, so let's take the secant, let's put in 0 for x. Well, you still get the secant of 0, which is 1, so at least one thing hasn't changed. Alright, so the secant of pi over 2, if you put in pi over 2, you would actually end up getting the secant of pi, which is negative 1. And then if I put in pi, I would get the secant of 2 pi, which is actually positive 1. Okay, if I put in negative pi over 2, I'll end up getting the secant of negative pi, which is negative 1. And then if I put in negative pi, I'll get the secant of negative 2 pi, which is positive 1. So as you see, I'm going from negative pi to pi. Everything's finished. We have 2 periods here. Everything's finished in a period of pi, with your asymptotes this time at x equals odd multiples of pi over 4. Okay. And you knew it was coming. I have to do one with the cosecant. Of course I do. Now this is going to get fun. So we're going to do f of x equals the cosecant of 1/2 of x. F of x equals the cosecant of 1/2 of x. So your amplitude's still 1. Now your period, you're going to take 2 pi and divide that by the 1/2. You actually get a period of 4 pi. So let's plot all of our critical points on the graph. So you actually have a period of 4 pi this time. Here's 3 pi. Here's 2 pi. Here's pi. Negative pi. Negative 2 pi. Negative 3 pi. Negative 4 pi. All right. So the period's extended all the way to 4 pi, so we have 2 full periods from negative 4 pi to positive 4 pi. Okay. Well, guess what? That is definitely going to affect our domain and asymptotes. What's true about the cosecant function in general? Where is it undefined? In other words, where are your asymptotes? It's normally going to be at integer multiples of pi over, of pi, right? If you take those integer multiples of pi, divide it by that 1/2, you end up getting 2 pi, right? So your asymptotes would actually be at even multiples of pi. X equals even multiples of pi. Because, for example, you take pi divided by half, you get 2 pi. You take 2 pi divided by half, you get 4 pi. So at 3 pi, you're fine. At negative pi, you're fine. Negative 3 pi, you're fine. It's those even multiples of pi where you're not fine. So x literally equals even multiples of pi are your asymptotes. That means your domain is x, all of x not equal to even multiples of pi. Your range still hasn't changed. You don't have any vertical shifts or amplitude changes, so your range is from negative infinity to negative 1 in union with 1 to infinity. Let's graph our asymptotes. Well, 0 is still an asymptote. Normally pi would be 1, but that would give you pi over 2, which is defined, so 2 pi is an asymptote this time, because you would have the cosecant of pi, which is undefined. 3 pi would actually give you 3 pi over 2, so that is defined at 3 pi over 2, but 4 pi would give you the cosecant of 2 pi, which is undefined. So as you see, it's just going to be at even multiples of pi. So 0 is already 1. Now the next one's negative 2 pi. And then we got negative 4 pi. Okay. So let's put in pi for x. That would give you the cosecant of pi over 2, which is 1. And then, let's see, put in 3 pi. That would give you the cosecant of 3 pi over 2, which is negative 1. Put in negative pi. That gives you the cosecant of negative pi over 2, which is negative 1. If you put in negative 3 pi, that gives you the cosecant of negative 3 pi over 2, which is positive 1. So there is your graph with a period of 4 pi, 2 full periods from negative 4 pi to positive 4 pi, with your integer, with your domain being x not equal to even multiples of pi, which means your asymptotes are x equals those even multiples of pi. All right, last two. We're on the home stretch here. We're going to do several transformations. It's only right that we do it, though, because in the real world, you're going to be tasked with having to graph a lot. I mean, having to really make a lot of changes. So, f of x equals negative 3 minus 2 times the secant of 2x minus pi. So we have multiple changes occurring. We have negative 3 minus 2 times the secant of 2x minus pi. Let's deal with the amplitude first. What is the coefficient on the secant? That's negative 2. So take the absolute value of negative 2, you'll actually end up getting an amplitude of 2, which right away affects our range. Normally it's negative infinity to negative 1 and then 1 to infinity. Well, that amplitude of 2 is going to start our range out with negative infinity to negative 2 and then from 2 to infinity. Now, what else do we have? We have a vertical shift down 3, right? Because of that negative 3 in front of it. So that changes our range again. If you subtract 3 from the members of the range, you'll actually end up from negative infinity to negative 5 in union with negative 1 to infinity. So that just affected our range. We definitely have a reflection in the x-axis, right? Because you have a negative on the secant. So we have a reflection in the x-axis. Okay. Now the period, the coefficient on the x is 2. So your period is going to be 2 pi divided by 2. That's going to give you a period of pi. At this point, we have enough to actually plot the critical points. Here's going to be 3 pi over 4. Here's pi over 2. Here's pi over 4. Negative pi over 4. Negative pi over 2. Negative 3 pi over 4. And then negative pi. Alright. So there's everything plotted. Now, we also need to figure out what the vertical shift is. I mean, the horizontal shift. If you take that 2x minus pi, set that equal to 0, what do you get? You get that 2x equals pi, x equals pi over 2. So you actually have a horizontal shift to the right, pi over 2 units. So horizontal shift right, pi over 2 units, which means everything's in our domain and our asymptotes are going to be affected. Okay, so we have a couple factors here actually working against our asymptotes and our domain. Let's just go based off the period first. Let's just base it off the period. If you divide what are your normal asymptotes at the secant? That's going to be at pi over 2, right? So that pi over 2 is actually going to become pi over 4 because your asymptotes then you divide everything by 2, so x equals odd multiples of pi over 4. But we're not done yet. We also have the horizontal shift right, pi over 2. Good news for us though, if we add pi over 2 to that pi over 4, we get 3 pi over 4. If we add it to negative pi over 4, you get positive pi over 4. So actually, this is staying the same asymptote-wise, which means your domain is going to be x is not equal to odd multiples of pi over 4. Alright, so let's draw our asymptotes here. Definitely pi over 4. Definitely 3 pi over 4. Negative pi over 4. And then negative 3 pi over 4. Okay. So the secant, if we start at 0, that would give us a secant of negative pi, which is normally negative 1. If you multiply that by negative 2, you get positive 2. Now subtract 3 from that, you'll get negative 1. So you'll actually end up getting negative 1. And it's actually going to go down like this because it's reflected. You have a reflection in the x-axis. Alright, now put in pi over 2, you would end up getting the secant of 0 Well, yeah, you'd end up getting secant of pi minus pi is 0, which is 1. However, if you take negative 2 times that, you get negative 2 minus 3 is actually negative 5. No, actually, it's not like that. I went the wrong way. I had a brain fart a minute. You're going to be going up here at negative 1. And then you'll be down to negative 5 here at pi over 2. And then you should get the same thing at pi. If you put in pi, you would get the secant of pi, which is negative 1 times negative 2 is positive 2 minus 3 is negative 1. And then negative pi over 2, that's going to end up giving you negative pi minus pi. Secant of negative 2 pi is 1 times negative 2 is negative 2 minus 3 is negative 5. And then guess what? At negative pi, it actually becomes negative 1 again. So you notice the alternating patterns. It alternates. So actually you can kind of predict what the values are going to be. It just alternates for each of the defined values. So here is the graph of the original secant of x function shifted to the right pi over 2 units, reflected in the x-axis with a vertical shift down 3 units, and a period change of pi. And we got one more, and guess what? Yep, you guessed it, it's going to be on the cosecant. And then we're done with the lesson. Actually, that should have stayed the same. But that might not. We'll see. Let's see here. So f of x equals 2 minus 3 times the cosecant of 2x plus pi. So here it is. So f of x equals 2 minus 3 cosecant of 2x plus pi. Well, let's look at the amplitude. The coefficient on the cosecant is negative 3, so the amplitude would be absolute value of negative 3, which would give you an amplitude of 3. So that is going to affect your range, which would normally be negative infinity to negative 1, turns us into negative infinity to negative 3 in union with positive 3 to infinity. But that's not it for the range. What do we also have here? We have a vertical shift up 2 units because that's a plus 2 next to the cosecant. So what does that mean for our range? We got to add 2 to the members of the range. Negative 3 plus 2 is negative 1. And then 3 plus 2 is 5. So your new range is negative infinity to negative 1 in union with 5 to infinity. Alright. Now, we still have a reflection in the x-axis because this is negative. That's a negative on the cosecant. The period is that 2 pi divided by that coefficient of 2 on the x, so we still have a period of pi. And at this point, we have sufficient information to at least plot the critical points. So let's go ahead and do such. Here's pi over 2. Here's pi over 2, 0, negative pi over 4. Whoops, I can't have 2 pi over 2s. That's pi over 4. Negative pi over 2. Negative 3 pi over 4. And negative pi. Alright, so the period is going to be pi. Now, let's see what the domain's going to be. Well, first let's figure out our horizontal shift, which will affect that. If you take that 2x plus pi, set that equal to 0, you would get that 2x equals negative pi, which would give you x equals negative pi over 2. So that means you have a horizontal shift left pi over 2 units. Alright. Now we know what we need here. So, where is the cosecant of x normally not defined? That's normally integer multiples of pi over 2, right? I mean, integer multiples of pi, correct? However, if you're shifting everything to the left pi over 2 units, that's going to become odd multiples of pi over 2. So this is almost going to behave a lot like the secant function. So the domain is going to be x not equal to those odd multiples of pi over 2. All right. So let's graph our asymptotes here. Actually, it's integer multiples of pi over 2. That should be integer multiples of pi over 2. Everything shifted to the left pi over 2, so it would be any multiple of pi over 2. Whether it's positive or whether it's even or odd, positive or negative. So any multiple of pi over 2 will not be able to be accepted. Which makes sense because normally integer multiples of pi, if you divide that by 2, you would get pi over 2 for your asymptotes. The integer multiples of such. So I got asymptotes at negative pi over 2, 0, pi over 2, and then pi. Okay. So let's start with pi over 4. If x is normally pi over 4, you're going to end up having this 2 times pi over 4 is pi over 2, plus pi is 3 pi over 2. The cosecant of 3 pi over 2 is normally negative 1. If you take that times negative 3, you'll get positive 3 plus 2 is 5. So here's what you're... I didn't even finish that dang asymptote. I thought I did. There we go. Okay, now, what about 3 pi over 4? So 2 times 3 pi over 4, so that's going to end up being 3 pi over 2 plus pi. That's 5 pi over 2, which we know to be pi over 2. The cosecant of pi over 2 is normally 1, but take negative 3 times that, you get negative 3. Add your 2, you end up getting negative 1. Alright, let's deal with negative pi over 4. So x equals negative pi over 4. That's negative pi over 2. Plus pi is going to be positive pi over 2. Which the cosecant of positive pi over 2 is 1, times negative 3 is negative 3. plus 2 is going to end up being 1. I don't know why. Yeah, that ended up being, let's see, negative 3 plus 2 is, yeah, negative 1. Alright, and then last but not least, we have negative 3 pi over 4, which would end up giving you negative 3 pi over 2 plus pi. That would give you the cosecant of negative pi over 2, which is normally negative 1 times negative 3, that's positive 3, plus 2 is 5. So here is your wonderful graph of everything shifted. There is going to be the graph of everything shifted for you. With the normal cosecant of x graph, with an amplitude of 3, period of pi, with a vertical shift up to, a reflection in the x-axis, and a horizontal shift left pi over 2. Everything changed from the original cosecant of x. So that's it for this lesson. The next lesson we will get into the graphing the tangent and cotangent functions. So I hope everyone has a great day. Take care.